The final example of the type 2 improper integral is to evaluate the integral from 0 to 2, 1 over x minus 1 squared. Now, you have to recognize that this is an improper integral. One of the common error people make is, oh, I know integrate 1 over x minus 1 squared is negative of 1 over x minus 1. And then you put the limit from 0 to 2, you end up, answer is, for x equal to 2, you get minus 1, for x equal to 0, you get a 1, and so in the end, answer is minus 2. And if you remember, you are actually finding an area from 0 to 2 of a function 1 over x minus 1 squared. And how can this area be negative when all the function is lying above the x-axis? So, the correct working should be the integral from 0 to 2 can be broken up as an integral from 0 to 1 and then plus integral from 1 to 2. This is because when x equal to 1, the expression 1 over x minus 1 squared goes to infinity. Now let's look at the integral for the first term from 0 to 1. The integral from 0 to 1 of 1 over x minus 1 squared. Now, the trouble is when x equal to 1. So replace the point x equal to 1 by L and take the limit as L goes to 1 minus. Okay? L approach 1 from the left. Now in this case, integration of 1 over x minus 1 squared is negative 1 over x minus 1. Put the limit from 0 to L, you find the expression is minus 1 over L minus 1 minus 1. And we let L go to 1 minus. So when when L is very close to 1, then you get 1 over 1 minus 1 will be very close to 0, and so the first term will be very close to 0 but negative because L is close to 1 but less than 1. So you have negative and positive. So you have positive infinity minus 1, which is the infinity. So the first improper integral actually diverge. Therefore, if any one of the improper integral on the right side diverge, the integral from 0 to 2 will diverge.